What is going on, everybody? Welcome back to another video. I hope you enjoyed the last video, or if this is the first video you're seeing by me, then welcome to the club. Today I had a question and I needed this question answered desperately. How effective would a 3D printed heatsink be on a CPU? So I went up and made my own model. I 3D printed it, and I have a few heat sinks to test it out and compare other things, and then I have some DIY heat sinks that I made just to see how effective the 3D printed one actually is. So let's get into it. So I started out by making a big square and then just giving a bunch of loop cuts to kind of spread everything out so I can select all these fins here. And then after I got that one done, I made a cross pattern and started to do a checkerboard pattern for the next heatsink. And boy, this took forever. I looked up a tutorial to see if I can just select a checkerboard pattern in Blender, but I don't think you can. If there is a way to do that, let me know, because this took around 15 minutes to do this. Anyways, after that was done, I didn't even print it. It was so big and large, it would take multiple hours. So I just ended up not doing it, and I'm horrible at Blender, so you can see here I don't even know what's happening. I've got an idea in my brain, but it is just not working. So eventually I figured out how to do it, and it rendered that one. Then I put it in my 3D modeling software, and oh boy, 12 hours on the printer. Yeesh. Anyways, so I sliced that boy up, sliced that guy up, and sent it off to the printer. Alright, that took like 30 minutes. So it said that the heat sinks are going to take around like 14 hours, but this one is 6. So we got 6 hours and 8 minutes. We got it over here. Oh, that's my IP address. And then if we come into the cave, ready over here. I have trust in my 3D printer though. I believe he will do it. Alright, this thing is done printing. It is quite large. Here's heatsink 1. It is exactly, let me grab my calipers. I did not actually do any measurements of the CPU whatsoever. So we have 71.5 millimeters, 72 millimeters by 48 millimeters, and the fins are 4.5. So we have our computer here. I want to see how effective using a 3D printed heatsink is. But we're looking at around just normal load with Streamlabs running in the background at 39 to 40 degrees Celsius. And we are going to just remove the CPU cooler and see how fast it takes to thermal throttle. Real quick, do not do what I am about to do to your own computer or system. Keep your CPU cooler on at all times unless your computer's off, obviously. Anyways, back to the video. What am I doing? I don't need a screwdriver for these. This little heatsink, it looks like the exact same size. So let's go ahead and remove the CPU while it's running. So we're going to watch the temperature while I do this. And if it starts to climb above 40, because it has not gone above 40 the entire time, then we know that the pressure and the, what's the word? Holy brain fart. That is crazy. I'm just gonna leave this whole clip. That's tragic. It's touching each other. The contact. We know that the contact will not be as efficient. Oh, we just jumped up to 41. We're now pulling up to the mid 40s. All right, what I'm gonna do, I'm taking off this front thing. So I'm gonna take the front case system fan. I'm gonna set it on top. I'm going to set it on top of our little 3D printed heatsink and see if that brings it down. We're still hitting 85. What if we just simply set this like that. So it's blowing air that way. Oh my gosh! I pushed it. So we're gonna see if it gets any cooler. Now, obviously, the freaking 3D printed gigantic heatsink didn't work very well. Now, I think there are a few reasons for that. A, it's plastic. B, it's TPU. And C, it was not printed at 100% infill. So there's a lot of air in there. It was printed, I think, at 15% infill. Only 15% of the actual inside is plastic. And the other 85 is just air. Maybe if I did this whole experiment again and did 100% infill, it might be a teeny bit better. As you can see by the just flat 85 degrees while it's thermal throttling, it did literally nothing. But don't worry, that's not all I have for you. There's more. I'm gonna cut to that now. So let me just cut in real quick. I wanted to see if I had any other heat sinks to test out that were just laying around, and I found my old heat sink, and I just wanted to see how good it was at cooling down a CPU with no fan. So I'll cut to that now. Temperature didn't change a single bit. Just gonna set that on there. Does the mounting hardware line up? Oh my, dude, this thing is, crazy. Look at that temperature drop and the temperature spikes. There's no fan on here. I mean, I don't know what I expected. I just didn't think it was going to be that effective. Okay, we're just going to put this rather beefy heatsink just right on the CPU. Instant. That was so fast. That was so fast. The instant I put it on there, it shot down to 33 degrees. We are getting almost better. We're almost getting better thermals with this heatsink and no fans than we were getting just the normal stock. Like, I knew heatsinks were obviously extremely effective. I just didn't know to what extent. I don't know what I expected. The mass-produced copper heatsink built for cooling CPUs was really good at cooling a CPU. It was interesting watching how fast the CPU cooled down. I will give it that. But I found an old heatsink off of a spare motherboard from the previous video, and I just thought to myself, why not? Let's see if that works good as well. So I'll cut to that. All right, we have peaked. We're at 85. We're now thermal throttling. We're going to slap on this baby itty bitty heat sink. Whoa, that fast too? Oh my god, that's hot already. Whoa, what? I'm grabbing a thermometer. Whoa. I don't want to touch it now. Why would I want to touch that? It shot us down. Now the heatsink is super hot. And it's just passively cooling. It cannot cool it. So I'm going to slap this fan right there and see if it does anything for it. There we go. So now this fan's blowing heatsink. It's cooling off some of this air. Oh, that's really hot. We got to 130 degrees, so. But now we're no longer we're just cooling the CPU with this tiny heatsink. We're still getting 135. It's going up. We're not pulling our max wattage. But we're not thermal throttling. If the CPU needs to be hot, it's not thermal throttling. We're staying right at the degrees at temperature. So really interestingly, that CPU heatsink, it was doing the bare minimum. It was keeping it just cold enough for it not to thermal throttle. So it was at 85 degrees, but just barely keeping it cold enough by dissipating enough heat that it wasn't thermal throttling. Anyways, it was like midnight when I was filming that, so I had the next day, and I'll just cut to the next day. All right, we're at day 2. My other 3D printed heatsink printed. It's this big. It is like a single millimeter bigger than this one. So we're gonna see if this one is effective at all in the slightest, All right, so just like yesterday, we are looking at 85 and 33 degrees. We're gonna put this little heat sink on and see if that brings down the temperature at all. So the little tiny one didn't work like at all either, which I thought the little one was gonna work a tiny bit better, but it didn't work at all. It got really like soft and like flexible. Maybe the clock speed went up by like 100 megahertz, but it definitely didn't do like anything. Now next, I wanted to see how efficient we could cool this CPU without using like a proper CPU cooler. So I kind of crafted my own little heatsink, and you're about to see what I concocted. Now we're at max temperature again, so this will be an easy way to see if these coins will be efficient at all. If adding these coins will make the heatsink more efficient because it's more surface area. Which it looks like it is. The coin is warm. The coin's actually warm. Now, is that enough to just cool the CPU while watching the video? It looks like it is. It looks like this little setup is enough to cool down the CPU with this little fan. Now I'm going to assume that over time, that the efficiency of our makeshift copper heatsink and coin CPU cooler will become less and less active as the coins warm up, and I don't think it's going to be able to cool off much. But now, surprisingly, the thing did work. If your CPU cooler broke and you didn't get paid till next Friday, but you still needed your computer, and all you had was a copper heatsink and $1.25 worth of quarters, it could get the job done until your cooler came in. Now, I did improve on my design, so I'll cut to that. I want to see what will happen if I rest this guy on top of the coins. Will we drop down even more? How do you think of that video? But it looks like it's more effective. I think this hot heatsink. This hot heatsink we're at. Now, I wanted to see if this thing could keep the CPU cool enough to play games. So I booted up Minecraft, and I'll go show you how it performed right now. It's struggling. It is definitely struggling when it comes to gaming on the quarter copper heatsink. 25 FPS with a 1% low of 3. We'll play a round of Skywars and see how it... Look, our God, I can't stop. I can't talk. Look, the CPU is not even maxed out because we have sodium on. We have limited our FPS to 30. And it's such a low power CPU that we're not even maxing out. So we're not even needing to go all the way to the most hot. Dude, no! Oh my gosh. No matter how good of a computer you have, you will never escape being trash. Now, obviously, I knew these 3D printed heat sinks were not going to perform well, but I didn't know they were going to perform that bad. I do think there is some room to, kind of improve on these 3D printed heat sinks. If I took the time to sand the face to kind of make it extremely flat, and printed at 100% infill just to make sure there was no air on the inside. Now, if you would like to see a follow-up video where I, sand down the edge and print at 100% infill, maybe find a different filament that is more efficient at heat dissipation, then let me know, because I would enjoy doing this all over again, because I did have a lot of fun. Now, it's no big surprise that this heatsink perform the best. I mean, it's the one you buy on Amazon. But what also surprised me is how weak this CPU is, that you could actually get by if you just were in a pinch for a little bit. You could still do your schoolwork if this is all you had, just a random heatsink off of a broken motherboard and some coin. But anyways, that is the video. Thank you so much for watching. Like and subscribe, and I will see you guys in the next video. Oh.